All right, so here's your first video on scientific notation, and what I've done here is I have scanned in all of the pages from your flip book. Okay, so I just have flipped up the top part here, and you can see this section on what is scientific notation. On the next page, it's the positive powers and so on. Okay, and I've also taken some time to fill in some of the writing so that the video is not as long. So up at the top here, what is scientific notation is a method of writing very large or very small numbers by using powers of 10. So it's always going to look like this, this some number here times 10, and that's being raised to an exponent here. Okay, and then just a couple things to point out that I wrote x here. X has to be a number that's greater than or equal to 1 and less than 10. Okay, so it has to be between 1 and 10. It can be 1, but it cannot be 10. So it can be 1 or anything between 1 and all the way up to 10, but not 10. Okay, so let's look at these numbers down here. The directions say to determine whether each of the following numbers are written in scientific notation. If they're not, write them so that they are written in scientific notation. So the first one here, 3.12 times 10 to the 7th. Well, we have a number, 3.12. It is between 1 and 10, and then it's being multiplied by 10, some power of 10, so 10 to the 7th. So here we'll write yes, this is in scientific notation. Number 2, 0.56 times 10 to the 8th. This is not written in scientific notation because the first number here, which we call the multiplier, is not a number between 1 and 10. So we can rewrite it by making it, instead of 0.56, we'll say 5.6 times 10. But when you change the decimal around here, it's going to change the power of the 10. Okay, and the rule that we use to change around these powers and move the decimals on the multiplier is LARS here. This is the acronym for it. So this means left add, right subtract. Okay, and what that means is if we're moving the decimal, so here we have the decimal here, we're moving it one space to the right so that we can write it as 5.6, a number between 1 and 10. That means if we're moving it to the right, we're going to subtract 1 from the exponent here. So we had 0.56 times 10 to the 8th. We're going to move the decimal 1 to the right, so we're going to have 5.6 now times 10, and then we're going to subtract 1, so it's going to be times 10 to the 7th. Okay, so that's how you can adjust your scientific notation there. So let's take a look at number 3, 91.2 times 10 to the 3rd. This also is not in scientific notation, okay, and it asks us to write it in scientific notation. So we have the decimal here. We're going to move it 1 to the left, and according to our acronym up here, if we move it to the left, we're going to add 1. So now we have 9.12 times 10, and then we're going to add 1. It's going to be times 10 to the 4th. All right, so I've done 3 of them. There's 3 left for you to complete there. All right, so let's flip up one more page, and we're going to look at the positive powers, okay? So positive powers, this is meaning the exponent on the 10. These are used to represent very large number, and an example is the distance, like in miles or kilometers, between Earth and the Sun. It's a very large distance. So we can write these large numbers in condensed versions using scientific notation. Okay, so let's do number 1 and number 2 here. So rewrite this number in scientific notation. Okay, so we're going to, so the decimal is over here to the right, and we're going to see how many spaces over we're going to move it. So it's going to be 1, 2, 3, 4, 5, 6, 7. If we move it 7 times, then we will get a number between 1 and 10, 7.5. Okay, and then the 7 is going to be the power on your 10 here. So we moved it 7 places over to get a number between 1 and 10, and so the 7 becomes the exponent here. So let's look at this one. We want a number between 1 and 10. Oops. We want a number between 1 and 10 here, which is going to be, if we put the decimal here, 4.560. Okay, so if we want this number 4.56, we don't need to include the 0. The decimal starts here. We go over 1, 2, 3 spaces, and that becomes the exponent on the 10, the power of the 10. Okay, so you do 3 and 4 here on your own. And then now we're going to go the opposite way. So write each number in standard notation, okay? So we have this number 7.8 here, and the decimal is starting in between, okay? And we need to move it 9, the exponent is 9, so 9 places to the right here, okay? So we have 7, 8, so you can see we've already moved the decimal here once, okay? We need to move it 9 times, so we're going to do this 8 more times, but really that just means we're going to put 8 zeros after here, okay? So where we have 7, 8, and then 8 zeros, so 1, 2, 3, 4, 5, 6, 7, 8. Good, and then you need to put your commas in, so for every 3 zeros we're going to have a comma in between, or for every 3 numbers anyway, we're going to have a comma in between. So there is that number written in standard form. Okay, and number 6, we have 1.009 times 10 to the 7th. The decimal is written here, and we need to move it over 7 times, okay? So if we write 1 and we have 009, we've already moved the decimal 3 times, so we need to move it 4 more times. So we're going to include 4 more zeros here, and then putting our commas in. All right, and you do the last 2, number 7 and number 8, on your own here. So flipping up one more time, the next page here we have our negative powers, and these are used to represent very small numbers. For example, the size of a dust mite. So that's measured, it's so small that we can use these a scientific notation to represent these incredibly small numbers, okay? So it is just the opposite of your positive powers with one exception, okay? So we are still looking at how we move the decimal. So here we have numbers 5 and 8, and we want to make this a number between 1 and 10, so we're going to choose 5.8. So we need to see how many times we need to move the decimal to get it between the 5 and the 8. So we have 1, 2, 3, 4, 5. So this is times 10. And here, since this is a number less than 1, you have they're behind the decimal, it's going to be a negative power. So it's going to be 5.8 times 10 to the negative 5. Okay. And the same thing over here, we have 403, we want 4.03 to make it in between 1 and 10, and we'll move the decimal 1 2 times. So this is going to be times 10 to the negative 2. Since we're moving it to the right here, it's going to be a negative number. Okay, so you do number 3 and 4 on your own. And then we'll move from scientific notation to standard notation, which is just regular numbers. Okay. And we have -7 is our exponent here, so we know we're going to be moving the decimal to the left 7 times. So we move it once to get it over the 6, and then 6 more times. So we can write 0 point, and then we're going to have 6 zeros, 1, 2, 3, 4, 5, 6, and then our 6 here, that will be the 7th position. There we have our 7, and then we'll just write what's after it. Okay, and then for number 6, we have a -12 here. So if we move the decimal once to the right, we'll need to move it 11 more times to get to where the decimal ends up. So if we write our decimal, we have 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 1, 3, 8. All right, so you do number 7 and number 8. we're going to move on to adding and subtracting these numbers, okay? So when you're adding or subtracting, okay, you're going to first write the numbers so that they have the same power of 10. That means the exponent on the tens need to be the same, okay? And remember, if you need to rearrange it, you need to use your LARS acronym, okay? So if you're moving the decimal at all, if you need the exponent to go up or down, you need to move the decimal to the left or right, and this is how you remember which way is which, okay? So after they have matching exponents, then you add or subtract the multipliers, which are the numbers out front, and keep the power of 10, and then make sure your final answer is in proper scientific notation. So let's do example number 1 here. Okay, first thing, check to see if our powers of 10 are the same, which they are. So then we can just add the first two numbers. So we have 4.3 plus 3.6, and that number will be times 10 to the 9. So that will be the same number here. Then we will get 7.9 times 10 to the 9. And there's your answer there. Okay? Same thing with subtracting. We're going to do, so we have the same exponent here, so we'll do 8.36 minus 2.16. We're just subtracting the two numbers, the multipliers out front, and then we'll keep the powers the same. So here we're going to have 6.2 times 10 to the negative third. Okay, and I'm kind of running out of time. Hopefully the bell doesn't ring during this video. You can do the last two on your own there. For multiplying and dividing, I'll do hopefully an example really fast. For this, you're going to multiply and divide the multipliers, which are the numbers out front. Oops, that's not what I wanted. Which are the numbers out front. Okay, and then use your laws of exponents to combine the powers of 10. Okay, so here we're going to take the multipliers and multiply them together. So a 3.2, and then we're going to multiply this by 1.75. And then we have our exponents here combined. So we have 10 to the 5th times 10 to the 3rd. Okay, 3.2 times 1.75 is 5.6. Okay, and then times, when you're multiplying numbers with the same base, all you have to do is add the exponents, right? So then we're going to have 10 to the 8th. And there's our final answer. It looks kind of sloppy there. I'm trying to rush. And with dividing, it's going to be the same. You're just going to split it up. So you're going to divide this. 7.68 divided by 4.8, that's 1.6. And then here, when you have a quotient, remember it's going to be the top minus, so the exponent on the top minus the exponent on the bottom, which will give us 10 to the 4th here. So then this will simplify to 10 times 10 to the 4th. And that is our final answer, okay? So hopefully that gives you a good start. You'll have your problem set to work on. And then we will do some more practice in class.